Okay, good afternoon. I'm here with Dr. Rob Windsor, and we're doing a little piece on our series, What the Heck Did the Doctor Say? Wherein we take some of the well-researched and clinically correct stuff that Rob's pulled together in the blogs and put it in English. So I'm going to start out with just a quick segment from the article, Do you know what a visceral microbiome is and how it's related to your health? So we'll go ahead and start there. The term visceral microbiome sounds pretty complicated. In reality,
it's really not that complicated. It's got to do, everybody kind of knows what's going on here. Your gut impacts the way you feel. If you're bloated, if you're constipated, you don't feel good. You feel a little down, you may not sleep as well, you're not as articulate, you're not as on it, and you just feel kind of glum. And vice versa, the social environment, whatever is influencing the way you feel, can also adjust the way your gut is behaving. You might have diarrhea, you might have cramping, you might have heartburn. So everybody knows that the gut is kind of integrally related to your health. So that at its 20,000 foot description is what a visceral microbiome is about. It talks about how your gut's bacteria and the balance of the bacteria in your gut will influence your health, and also vice versa.
all right, the first one we selected, and I'm actually going to have Dr. Windsor read it because it's got big words in there that I stumble over, and it ties into visceral microbiome. Here you go, read the first one.
Okay, the sentence he's highlighted is, treatment with B. fragilis, that's Bacteroides fragilis, ameliorates some of these behavioral changes in the offspring. Identification of changes in the serum metabolome, small molecule chemicals found in biofluids or an entire organism, associated with such treatment led to the identification of several bacterial metabolites that could explain this effect.
Yeah, see over here?
So okay,
explaining it to me.
That was done in a mouse model.
Right.
The study was done using mice, and pregnant mice, of course female mice. They injected the mice with a virus that when the offspring were born, the offspring would demonstrate something like autism. Now, to ameliorate or thwart or weaken or improve the status of the autism, they injected these newly born offspring with this bacterium called Bacteroides fragilis. Now, it is doing that caused amelioration of the autism-like behavior patterns.
So it fixed it.
Made it better. And they assumed it's either a direct impact of the bacteria or waste products or metabolites of the bacteria that made the mouse offspring improve.
Right, and not having it obviously manifesting itself in those autistic-like behaviors.
Right.
Okay, cool. All right, the second one we've highlighted here today. We'll dive in.
Newfield and colleagues used female germ-free mice to demonstrate that the absence of a conventional microbiota results in a reduction in anxiety behavior in the elevated plus maze, a well-known, validated model of anxiolytic action. Okay, so the emphasis there is that by taking the normal bacterial flora away, adjusted the anxiety-like behavior of these mice. Again, demonstrating a correlation between the bacterial balance you've got in your guts and your well-being.
And it's amazing how strong that can be.
There's also evidence that it works the other way around. This is what I was mentioning earlier. The status of the brain can influence the status of the microbiome. Restraint stress is shown to disrupt the microbiome in mice, leading to an increase in colonization by Citrobacter rodentium, possibly by altering the local mucosal microenvironment so that the bacterial adherence patterns change. More recently, it was demonstrated that exposure to as little as 2 hours of social stressor altered composition of the colonic mucosal associated microbiota.
Now, like dinner with your mother-in-law can affect your microbiome. 2 hours, you're all
I
done.
got it. Yep, that's fine. Yeah. So basically, they looked at the colonization of these mice gut flora. They tied them up for 2 hours, and the colonization changed. And so, with as little as 2 hours of social stressor, the balance of the bacteria in the mice's guts changed. And that kind of demonstrates that the brain affects the gut, and the gut affects the brain.
Circular reference.
Right.
Pretty strong.